Hi there. Today's lesson will be on special right triangles. The first special right triangle we'll talk about is the isosceles right triangle. An isosceles right triangle has two 45-degree angles and a 90-degree angle. And because it's isosceles, it has two congruent sides. There's a very special relationship with the isosceles right triangle. Whatever the two side lengths are of the short side, which we'll call x, the hypotenuse, which is always going to be opposite our right angle, will be whatever that side length is times the square root of 2. Okay, so that relationship is always going to happen. For example, if I told you on this triangle that the side length here was 5, first of all, you would automatically know that because these two sides are congruent, that this side was also 5. And the third side, the hypotenuse, is 5 times the square root of 2. And what we like about these numbers is that they are exact. We don't want the decimal approximation. So let's take a look. Looking at this, number 1, I gave you the hypotenuse. Whoops, I'm sorry. I gave you the leg, which was 15. So we know automatically that this side is also 15. And remember, this side is x, this side is x, and this side is x times the square root of 2. So whatever we have here, we just drop in for x, and we know that the hypotenuse has a length 15 root 2. If you look at number 2, you might notice that something is a little bit different here. And what's different is that I gave you the hypotenuse in this case. So I'm giving you the side that is the x root 2 side. So what we have to figure out is how long are each of these sides? Well, what we have to do is we have to essentially solve for x. So we would divide by root 2. Now, you know better than to give us an answer with a square root in the denominator. So what we have to do here is we have to rationalize. So we will multiply this by root 2 over root 2. What we get for our side lengths will be 23 root 2 over 2. And if you recall, what we did here is we actually created a perfect square, which was root 4, and the square root of 4 is 2. So just so you know why that happened. So this side will also be 23 root 2 over 2. Let's take a look at number 3. Number 3, I gave you the length of the short side, or the leg, which means that this will also be 7 root 10. Now recall the hypotenuse is x root 2. So our x value is 7 root 10, and we're going to drop that in here. So we'll have 7 root 10 times the square root of 2, which will give us 7 times the square root of 20. Now, hopefully you can kind of look at that 20 and say, wait a second, I know there's a perfect square that goes into 20. 20 can be broken down to be square root of 4 times the square root of 5. So in cleaning this up and expressing it properly, we would clean that up and make the square root of 4 2. And 7 times 2 times root 5 is 14 root 5. And that is the exact simplified length of this hypotenuse. Okay, looking at number 4. Number 4, once again, you have been given the x root 2 side length, and we have to calculate this side. So we're going to divide by root 2. Okay, and just like number 2, we can't keep that. We have to clean that up a little bit. So we're going to multiply by root 2 over root 2. What we get is 12 root 2 over 2. And we're not quite done yet because the 12 and the 2 here, not the value under the radical, but the 12 and the 2 can be reduced. So we must do that if we can, and we get 6 root 2 for each of these sides. And that's how long they are, exactly. So that's your 45, 45, 90, also known as the isosceles right triangle. The other special right triangle is the 30, 60, 90. So when I look at this triangle, I like to always highlight the short side because the short side is always expressed as x. The hypotenuse is always twice as long as that side, so it's 2x. And the medium side, which is opposite our medium angle, is always going to be x times the square root of 3. So how does this work? Well, again, let's look at this problem. I'm going to highlight this side and I'm going to label it x. I know that this is my hypotenuse, so this is 2x. And this is my medium side, so this is the x root 3 side. So looking at this, I can see, okay, in order to solve for x, I have to divide by 2. 26 divided by 2 gives me 13 for the short side. And now I just take that 13 and I drop it right in here for x, and I get 13 times the square root of 3. Okay, so each side, these three sides land in a very special ratio. So example number 2, again, these are all facing the same way, so it's kind of easy to pick out where the short side is, but the short side will always be opposite the 30-degree angle. The hypotenuse will always be opposite the right angle. And opposite the 60-degree angle is the side represented as x root 3. So in order to solve for x, in order to get the length of this short side, we must divide by root 3. And we would have 24 over root 3. So I'm going to write that up here. I'm sort of out of room down there. 24 over root 3. Well, just like in the previous problem, we're not allowed to have an answer with a radical in the denominator. So we will rationalize by creating a perfect square in the denominator. And what we get is 24 root 3 over 3. Now you have to ask yourself, can 24 and 3 both be divided by the same number? And of course the answer is yes, they're both divisible by 3. So we clean this answer up and we find that x is actually going to be equal to 8 root 3. Once we have that side length, we take this number and we drop it right in here for x. So we'll have 2 times 8 root 3, which will be 16 root 3. And that's the long side of the triangle. So just like the 45, 45, 90s, there's a very special ratio, very special relationship among the sides. You always have to solve for x. You have to make sure that you rationalize or reduce when possible. So let's practice a couple of problems, and you'll notice that these triangles are facing different directions. So again, what I do is I like to highlight the short side, and I call that x. I know the side opposite the right angle is 2 times x, and the medium side is x times the square root of 3. So these are the easiest ones because I gave you the x value. So we're just going to drop that right here. 2 times 16 tells us that we have a hypotenuse of 32. And if I drop the 16 right in here, I have a medium side length of 16 root 3. Number 2. Again, here's my short side. I like to do that one first. That's going to be x. The side that I was given was the hypotenuse, which is represented by 2x. And the medium side is x times the square root of 3. So what I'm going to do here is I'm going to solve for x. So I will divide by 2 on each side, which gives me 13 over 2. To be honest, I don't want to see 6.5. 13.2 is nice, it's precise, and it's the, usually we don't have a decimal. We're going to actually put it in with our radical here. So usually we don't have a decimal with a radical. So now we're going to take that 13 over 2 and we're going to drop it in right here for x, and we will get 13 root 3 over 2. And that's the length of our medium side. Okay, looking at number 3, here's our short side. The hypotenuse is 2x, that's over here. So we've been given the x root 3 side. So in order to solve for x, calculate the side length, we have to divide by root 3 on each side. We know, of course, we're not allowed to have a radical in our denominator, so we multiply by root 3 over root 3. What that does for us is it gives us 18 root 3 over 3. And you have to ask yourself, can I reduce the 18 and 3? And of course you can, so you wind up with 6 root 3 for the short side of the triangle. And that's our x value. So now we'll take that and we'll drop it in right here. 2 times 6 times root 3 gives us 12 root 3. And that's the longest side length and the hypotenuse. Number 4, same routine. So here's our short side. We label that with x. Our hypotenuse will be 2 times x. And the medium side will be x root 3. So as we did before, we will solve for the x value. So we'll divide by root 3. Of course, we're not allowed to have a radical in our denominator, so we're going to clean this up a little bit. This gives us a short side of 10 root 3 over 3. And there's nothing to simplify there because 10 and 3 can't be reduced. And now we take that x value and we drop it right in here. So 2 times 10 root 3 over 3 gives us 20 root 3 over 3. And that is the exact length of our hypotenuse. Let's turn the page. So the first 2 problems I will go through with you, and I'm going to say this. You need to memorize the side lengths associated with these triangles. What you will notice is the hypotenuse of each of these triangles is 1. Okay, and this is going to be very, very important for the next few chapters as we study trigonometry. We will be working with something called the unit circle. So that's all I'm going to say right now. It's a little preview of what's to come, but you should definitely memorize these side lengths. So we have x here, we have x here, and this is our x root 2 side. Remember, this is the 45, 45, 90, so it's x root 2. In order to simplify, or I'm sorry, to solve for x, we divide by root 2. You know, we're not allowed to keep that radical in that denominator, so we will rationalize it by multiplying by root 2 over root 2, which gives us root 2 over 2. And this side also will be root 2 over 2. So those are the lengths I need you to know. I need you to know root 2 over 2, root 2 over 2, 1. Okay, you're going to memorize those. When we move on to the 30, 60, 90, okay, again, this is a special triangle. It's a 30, 60, 90, but it's special also because the hypotenuse is 1. Our short side is x. Our hypotenuse is 2x. And our medium side is x root 3. So to solve for x, we would divide by 2 on each side, which gives us an x value of 1/2. And now when we take that 1/2 and we drop it in right here, we get 1 times root 3 over 2, which can be cleaned up to be root 3 over 2. So numbers I need you to memorize here. 1 for the hypotenuse, 1/2 for the short side, and root 3 over 2 for the medium side. Okay, that's the reason we're practicing all these triangles. But these 2 triangles right here, I want you to just memorize, even if you have to draw them out 5 times each. Okay, You are on your own for the rest of the problems. Follow the process, take your time, rationalize when necessary, and hopefully we'll be all set. Have a great day, everybody.